feel like I get it, and then as I read more, I get more and more confused.
Okay.
I guess what's throwing me off is when we're talking about consider something to be significant
Yep.
versus not significant. I guess that's what's, for instance, in the article, the example that was given about the patient that when we turn them, the probability of such a specific action is low because it may be lessened by the nurse's action. It may be lessened by the nurse's action, or it may happen anyway. That is, it may happen by chance if the pressure sores are prevented. So then, what are we saying is significant or not significant? I guess that's what's throwing me off. Are we saying by the nurse's actions, are we focusing on that because that's the intervention? Or are we focusing on the sores and that even if we don't do anything, they still may not develop pressure sores? But if we do, does that make sense?
It does. I appreciate your question, and I think that I hope to answer that question
Okay,
by our discussion today.
okay.
So, one of those things where, as an educator, you have an initial approach that you think is grand, and you articulate it, and in your mind, it sounds like a great idea. But if the students don't receive the instruction that was given, then it didn't work, okay? So what my job is as an educator is that if the first time it doesn't work, then that means I need to change my game plan. And that's what I hope I intended to do with this session. So the intention was, with the probability, is to give you some context of what the actual probability theory is, okay? And how we actually get to that number of probability when we're talking about the null hypothesis and the hypothesis, right? And identifying that avoiding a type 1 error when the null hypothesis is true, right? But you reject it, okay? Instead of accepting the null hypothesis, okay? So that's the first part. The second thing is that when we look at statistics, any statistical analysis that you produce or run or test is going to give you an output of a probability of that statistical analysis. So your p-value is actually going to give you, based on that run statistical analysis, what's the probability of that statistics actually proving the null hypothesis or not. That is the probability, and that is a number that we look at or see in a decimal or as a percentage. The clinical significance is whether or not if the p-value is either meeting or not meeting the measured clinical significance. And the clinical significance is that 0.05 or that 5% threshold. What we're going to talk about today is probability, statistical significance, confidence interval, and a confidence level, right? And I'm hoping that by introducing more terminology that it will help explain probability. I think the error where it kind of got convoluted was my intention to hold back the information and not give you too much information, just really focusing on probability, that not really giving the true context of how it all works together was probably missing the point that I was trying to make, okay? The other thing that we need to be really clear about is that when we introduce a new term or methodology or practice, we won't get it in the first go round. And we'll revisit it. And my intention is that we'll continue to revisit it until this is a concept that you feel like you can handle a little bit more. So today I'm going to use a couple of different methodologies. I'm going to go over a brief lecture, and then I found 2 more videos, okay? So hopefully with the dynamics of looking at different methodologies of how people learn, hopefully by me talking and then having a good tangible illustration that with video will hopefully elevate the concepts, and then we will go over the actual article that I gave to you for application. Okay, so we'll hit all three of those. And I'm hoping that by doing that step by step, we'll have a better understanding. Okay. Did everybody read the article last night? Did everybody bring their article with them?
Yes.
Okay. If you don't, guess what I have? I have extras.
I'm gonna have to
See, there we go. See, I like
On
that.
my computer, but not printed out.
Yeah, I like that. And so what I like to do is actually have a piece where you can write, right, on the article, and then you can take notes, and then you can reference all of the tools and, pieces of information that we get from our class discussion. Any extras, can you, pass them up to Catherine? And then I'll take them.
Today.
Yeah, hold on to them, yeah, if you wanna get your colleagues a copy, that's fine too. And so what we're gonna do even further, is I have some questions that I'm going to have you all to discuss in a small group, and then we'll come back as a large group, and then we'll talk about the article. So statistics. We've been talking about descriptive and inferential statistics, and I think we have a really good handle on descriptive statistics. Talking about central tendencies and measures of dispersion. So where we've translated now is to inferential statistics and understanding how we actually use statistical analysis in producing some value or interpretation of a sample or a sample set of the population. And specifically what you all will be doing is using these methodologies for your project that you're doing with your practicum experience. So what we want to do with statistics is we want to compare and contrast descriptions about your samples. And you want to test whether or not if there is some relationship between your variables, or if there's a difference between the groups that you're measuring, okay? So we're looking at whether or not if there's a difference between the groups, or if there's a relationship between the variables. And so by running a statistical analysis, what you're able to do is make inferences, or actually make assumptions, if you will, based on your small sample to a larger population. What we're gonna be looking at is correlation or causality. I thought that the article that we're gonna talk about later, depression is a risk factor for incident in coronary artery disease in women, I thought was a really good article. So considering that nurses are primarily women, sorry Nathan, and it's a good sample of what nurses look like, I thought this was a good study to look at. And really talking about whether or not if an independent variable is a causality to the dependent variable. So whether or not in this particular study, does depression predict incidences of coronary artery disease and the different types of coronary artery disease, specifically looking at whether or not if it caused death or any other type of coronary artery event. So they had two different outcomes that they were looking at. And so whether or not if you can infer from that sample that they used, which was over about 860 sets of women over an 18-year period, right? Whether or not if that sample can be related to the larger population. So we'll get into the statistics about that. So we've been talking about the statistical significance versus clinical significance. And when we talk about significant findings, we're looking at whether or not if there's a variance that can be explained. If in the study design, if there is a control that can be eliminated or that can have an unexplained variance and a detection of a statistically significant difference between the two dependent groups, which they actually had a primary outcome and a secondary outcome related to depression. So when we talk about clinical significance in a small sample in a study, it can very well demonstrate statistical significance, but it does not necessarily mean it will translate into clinical significance. And so that's where we wanna kind of really draw the distinction between the two. Because we know that, I don't know, a good example is if someone that is obese, if they, I don't know, do a lifestyle change in their diet and they stop drinking sodas, statistically, you probably will show that the less consumption of carbonated drinks will reduce a person's weight, right? But we already know that, so it may not have clinical significance, but a study may demonstrate statistical significance, okay? It's not really gonna change anything for us clinically of how we practice. So that's a good example of us talking about statistical versus clinical.
So, but our goal would really, if we were to continue to pursue research, yes, it's easy, it almost seems like it's easier to achieve statistical significance as opposed to clinical significance, because with clinical significance, we can change practice and we can change the way we do things. So that is that like the goal?
Absolutely,
Okay.
because it's a culmination of how we get to evidence-based practice.
My question was, a couple days ago,
Yeah.
how do we take these statistically significant data and relate that into EDP? That was what I was trying to.
Oh, okay, so it's gonna be it's a culmination, right? You can't really have evidence-based practice over one study, right? So that's where you get your systematic reviews and you actually get a culmination or a meta-analysis. It's the culmination of multiple studies looking at a specific phenomenon over a period of time, making sure you have a robust sample that actually demonstrates and can be inferred to a larger population that yes, this particular practice will actually translate clinically. And the reason why using the obesity and the low carbs is not clinically significant is because we already know that. It's part of our practice already. But we should also be thinking about that when you do your study, right? When a study is intended to be done, when you're looking at a specific approach or a project, you wanna know that you're actually gonna make a difference, right? With the effort and the amount of time that you're actually putting into a project that's actually going to influence some type of practice in some way. You don't wanna reinvent the wheel of what's already been done.
So to me, some of the, like, there's a lot of basic research out there, which is great for illuminating the science of things, but when I worked more in that area, it was really hard for the scientists in that area to talk to people doing clinical trials, because a lot of what the basic science was instructing people to do was totally impractical to do with real people. And they didn't really understand that people have a will of their own and show up when they wanna show up and do what they wanna do, and why couldn't the nurses take this sample, centrifuge it, aliquot it into 10 different tubes, and everyone just stare at them like, you want us to do what?
What?
And they're like, well, don't you understand, this is how you have to, and they couldn't talk each
What
other's
translate?
language. And that was, to me, kind of the human epitome of going from something that's statistically significant in a perfect control world and trying to translate that to the people who actually have to apply it, to people who don't care about your centrifuge or your minus 80 degrees Caesar or anything else. They have to work in a real world setting. And so I think those worlds sometimes have a hard time coming together.
Sure. And I translate that in my mind, Amy, of what you just said, is comparing ideology to practicality, right? Ideally, yes, that's a great idea. And in that researcher's mind, it will translate into some phenomenon that he thinks is, right on the edge, is cutting edge. But practically, how do we, like you said, translate that grandiose idea into what nurses normally do, which is direct patient care? How is it going to really influence my practice so that I can influence quality, satisfaction, productivity, some of the things that you all are looking at in your projects, right? It has to be relevant. And if what we're doing on a daily basis is attempting to trying to move the needle to what we identify as AAA, low cost, increased satisfaction, and what's my third one? And better patient care, better outcomes, then we wanna make sure that we're testing and we're doing, analyses, quality improvement, or research projects on things that will directly affect how we practice. So statistically versus clinically. And if the study is done right, sure, you'll probably get a statistical significance, right? If you actually can disprove the null hypothesis, right? Which, looking at some of the videos, that's where we should start, is identifying what the null hypothesis is, and then it's our responsibility to prove the null hypothesis to be wrong. And how that occurs is identifying what your variables are, and then doing some form of statistical analysis, and looking at that p-value as to whether or not, if you can demonstrate that you're not rejecting that null hypothesis based on a statistical output, that type 1 error. Okay, so hopefully if I continue to use these words, it'll start to translate, okay? And again, just like we just talked about with triple aim, who should actually be judging clinical significance, right? Our patients, our families will determine whether or not if they have good quality care. We don't get to determine if it's quality care, right? Our work will stand for itself, which is how we get to meaningful use, which is how we get to value-based purchasing, right? Which used to be prospective payment or pay for performance, right? We have to get reimbursement based on how we perform. And if we're doing a good job, then now the insurance are saying, we can validate the monies that we're giving you. But if you can't validate and demonstrate to us that you're changing the quality of a person's or a family's life, then why should we reimburse you? Why should we pay you? So now here we are with identifying that our customers and consumers are identifying what's significant. We don't get to continue to hold the bag to say, because you were in the hospital for 20 days and we charged you a sum of money, that translates into quality. We don't get to do that anymore. We actually have a say-so in what's quality or not. Our own ability to say that we're satisfied or not satisfied, and our ability to say that when we walk away from a patient that we actually changed their day with the 8-hour, 12-hour day that you were there, that you impacted them in some way to get them out of that acute care setting, if that is the case, or outpatient setting, that you've improved their quality of life, that you can actually see that. And then society at large. We are one of the largest components of the healthcare industry. People respect us in society. Consumers raise an eyebrow and you say, yeah, I'm a nurse. Oh, you a nurse? Oh, wow. Let me ask you a question. You know, it automatically translates into, and you can see them going into their minds, a nurse, then that means that they have knowledge. I do know that I have this thing on my leg or my foot. I've had it for a long time. I don't know if I'll be able to get to go to the doctor. So can I ask you a question? So you can see the whole process going into their mind.
Yes.
They actually value what you think. They give credence and credit to the level of education that you've had as a nurse, right? How many of you know people who intended to be a nurse that aren't nurses? The most recent 2016, I think it is Press Ganey, has us as a #1 profession as far as ethics. So we've had that rating for some time now. So a lot of people want to be us, right? Because of what they see in the community and how you all perform at the bedside or in your place of work, and how you represent all of us as a profession, right? So we represent each other when we interact with people in our workplace or even in our families. How many of your parents are proud to say, my daughter is a nurse, my son is a nurse?
Their daughters are nurses.
Or my son is a nurse. My mom she lights up. Now that she gets to say, yeah, my daughter, she just finished doctorate. She just got her doctorate. I remember we were on the airplane going to, she actually left before me to go for the graduation, and so she was on the airplane. And you know, you exchange and have a conversation. Oh, where are you going? Are you visiting? Are you coming? And so my mom said that she was on the airplane and they asked her, "Where are you going?" "Oh, I'm going to my daughter's graduation." And the conversation ended there. So she didn't like that. She didn't like that. That wasn't good enough. Because, you know, when you have a conversation, we say, "Yeah, where are you going?" or "Where's she graduating in?" You know, you actually start a conversation. So now she didn't, so the next person that she talked to, she didn't even give them a chance to not ask her. So it was a prompted conversation. So she started, "Oh, where are you going?" And then they say where she's going, where they're going. "Oh, where are you going?" "Well, you know, my daughter is graduating from Loyola University out of New Orleans with her doctorate degree in nursing." So she goes through this whole dialogue. So she's not gonna even wait for you to ask the question, because I'm giving it to you, because I have something to say. So, we have people out there that are proud of what we're doing. So that good old P word, here we go. All right, so probability is usually expressed as that small italicized P, and it's going to be written in a decimal form. And really what it is out of 1, okay, or out of 100, a percentage. So if you have a probability of 0.023, then you'll see it in research statistically as a P equals 0.23, meaning that there is a 23% probability. In nursing research, we have our level of significance stated as a 0.05. The level of significance is stated at a 0.05 probability. Okay? So that means the level of significance, when it becomes significant with nursing research, is when that p-value is equal to or less than a p 0.05. Yes,
Can I say it with her example and see if it's right?
absolutely,
Just because sometimes if I say it out loud.
absolutely.
So your example was that turning the patient every 2 hours does that prevent pressure ulcers? So if I did a study like that and I got a p-value of 0.23, that means that there's a 23% chance that if I did nothing, just by a chance, that person wouldn't get a pressure ulcer anyway, which is the null hypothesis.
Correct.
Does that make sense? That does. So it's a 23% chance that your intervention had nothing to do with the outcome.
Correct. And what you're then proving then is that when it becomes statistically significant at 0.05 or less, you are now able to disprove the null hypothesis, stating that turning that patient will prevent the pressure ulcer.
So the value of 0.05 P is the probability of the null hypothesis being true.
And you rejected it, yes.
Because there's only a 5% chance that the null hypothesis was true, which is sufficiently low enough to say that what you did would make a difference.
Correct.
So it's significant if it's less than the 5%.
Equal to or less than.
So the point of the probability of 0.05 is only definable based on your hypothesis, your null hypothesis.
Correct.
Okay.
So this is all centered around, remember when I gave you that grid, it was all centered around the null hypothesis. This is all centered around the null hypothesis. If your null hypothesis is true, meaning that there is no significance, and I accept that there is no significance, that there is no relationship, that there is no difference, then I accept it. If statistically I reject it, then that means I'm actually getting a type 1 error, which is an alpha, right? Your alpha is your level of significance. So if I have one, no, it's your confidence level. Your alpha is your confidence level. So if I have one minus my alpha, and my alpha is P 0.05, what is 1 minus 5%?
95%.
It's 95%. So I have a 95% confidence level that what I am actually predicting is true. Did you guys catch that? Okay. And that's why your P is significant. Because I have a confidence level that what I'm intending to prove is 95% true. Okay, we're gonna do a video just to kind of make that live a little bit. Yeah.
So wouldn't we look at it like the 23% is a high probability? Is that a sort of easier way to look at it?
It is a higher probability, but you don't want high probability, you want low.
It's a high probability that
For
the
null.
opposite of what you're
That the
saying
null
is
is
true.
Okay,
And
okay,
so null is the opposite of what you're saying.
okay.
Because at the end of this, what this is really about is disproving the null hypothesis. We want to disprove the null hypothesis. We want to show that there is a relationship. We want to show that there is a difference. And the null hypothesis is saying, by nature, that there is no difference and that there is no relationship. Typically, in a hypothesis, you are trying to prove that there is a relationship and that there is a difference between your two groups or multiple groups. Okay, so your alpha is your level of significance. Okay? Meaning that if I hit that level, if I hit that actual numerical probability, then it becomes significant. 1 minus my alpha then becomes my level of confidence. Okay? 1 minus alpha becomes my level of confidence. My alpha is my level of significance. And I think where I went wrong is really trying to tell you that the probability has something to do with the type 1 error, and that was just kind of way up here. So I'm hoping, is this getting more clear when we're talking about level of significance, your confidence level, and your alpha? I'm gonna add a little bit, one more definition. And that is your confidence interval. So typically what you see in nursing research is that your level of acceptable significance is usually at 0.05. It can be lowered to 0.01. That's very, very low. Okay? That means you have to be 99% sure that you can disprove the null hypothesis. And that is a much lower threshold to prove. Okay? All of these, of course, are lower than 0.05. If you hit it, great. But what you want to set, nursing will set their level of significance is at that 5%. Okay? All right. Your confidence interval. Okay? We already talked about that your confidence level is 1 minus your alpha. And if my alpha is equal to my level of significance, and my level of significance is 5%, my confidence level is 95%. Typically in nursing research, you will see that researchers will use a confidence level of 95%. So that means when a test is done, 95% of the time, I'm going to establish where that 95% will be. I might have a high end and I might have a low end of what that target number will be. The low end and the high end is called the confidence interval, because it is a
It's a range of
It is a range of outcomes. Did you guys catch that? You caught it. Cause that means I'm 95% sure that I'm going to get a confidence level. It is a specific data point and a parameter. My high and low point will be the range of that interval, confidence interval. And my level of confidence number will be somewhere in that range.
No, if you have a confidence or significance level of 5%, confidence level of 95%, would you normally say that your confidence interval is, would split the confidence or the significance and place it at the ends of the outlier, or just at one end?
So no, so your confidence interval is actually gonna be a number based on the parameter or statistics that you're looking at, okay? So say for
Whatever
example,
you're measuring.
whatever you're measuring,
So for example, would you say that, like, if you're just purely numbers sake and
Yeah.
ease of example,
correct,
if your range of data points was like from 1 to 100, would you take 2.5 off each end and give that, or would that be, say that you're confident that my values should fall between these two ranges, or?
this is what the video, oh, here it is right here, this is what your video will show. When we're talking about a normal curve, right, with your mean, mode, and median centrally placed, and we have a normal curvature, okay? When we talk about the first set of standard deviations, right, this right here, these two data set points will be my confidence interval. Because my intention is to be right here in the middle. This is my confidence level right here. And my range, my interval, confidence interval, will be on either side of that mean. So as long as my results fits into that confidence interval, then I'm on target. Okay, we're gonna watch a video, so keep that in mind.
So you
Okay.
just split it in the
And the
middle.
number of standard deviations has to
45.
do, you remember when she was
Yeah.
showing you the number
Yeah,
of
yeah, I
standard
know that,
deviations is the confidence interval window that you've chosen, so it could, if it's
So you
super
really-
narrow, it could be a 99% confidence interval, which is that narrow, and if you make it more standard deviations, it'll be higher.
But, so, okay, so you'd really take your confidence interval and place it right over the data, the mean, median, mode, your data points in that format. Okay. You're over your normal curve, and then you look at your, okay,
If it's skewed,
then you have to adjust it.
okay? Because we want that number, because we're confident, we're saying we're confident that my data set point, if I really disprove the null hypothesis, my data set, the numbers in my data set for my sampling will fall in this range. If it falls out of this range, then it's not within my confidence interval, and it's outside of my confidence level of 95%. So remember when we talked about when your curve is long and wide, you have a very spread out data set. If you have a normal curve, your curve comes in more, right? And so all of your data set is right in the same spot. Okay, you are looking for a normal curve. Okay? You guys getting it? I see Stacy got a smirk on her face.
It's growing.
It's starting to process.
Okay. Video. What questions do you guys have before we go into the video?
No, I didn't.
Now, she's gonna start talking about chocolate-nutties, chocolate-nutties. She has a English accent. she's gonna talk about something that doesn't exist, but yet and still, I think it brings home the point. I hope that, my video, that's my sound.
One of the key outputs is the p-value of C.
Yeah.
Understanding the p-value. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data, one of the key outputs is the p-value, or C. In formal terms, the p-value is the probability that, if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis was true. We will now go through this step by step with an example. Helen sells choconutties. Recently, she has received complaints that the choconutties have fewer peanuts in them than they are supposed to.